In this video, we're going to be looking at circle theorems. This takes the information we know already about circles and about angles and adds it all together. So we already know if we have a circle, we can draw a radius. And if we have a radius on opposite sides of the circle, that's called a diameter. We also know we can draw multiple radius to any point on the outside of a circle. So if I have a point here and a point here, from the centre to that point is a radius. From the centre to the other point is also a radius. And all radius are the same length for the same circles. So that tells us that that and that are the same length. If we join these together, these points together with a chord, we have created an isosceles triangle. Remember, the properties of an isosceles triangle is a triangle with two equal sides or two equal angles. These properties come in very handy in certain questions. So radius will always give us, to 2 points on the outside edge, will always give us an isosceles triangle. Now, if I draw a diameter, that comes to 2 points on the end. We know that that gives us 180 degrees in the centre on one side, 180 degrees on the other side. We have an additional fact that's very useful. If I choose a point on the outside edge and I join these up, so this is 3 points on the outside edge with a diameter, can form a triangle. Oops. And that triangle is always at 90 degrees. Now, it doesn't matter where we draw our point, we will always get 90 degrees. So if I chose a point that was here, I'm still going to get 90 degrees. This is going to be hard to draw without accidentally erasing. So to the same 2 points, using the same diameter, any third point on a circle will form a 90 degree angle. Try it for yourself. You'll find that if you use a compass to draw your circle, you know where your diameter will go through because the compass leaves you the nice middle hole. If you take a protractor and measure all your angles, you'll find that it's always a triangle with a right angle at the outside edge. This is one of those ones that in a class you would get the kids to draw these things and you would get them to investigate and they would discover for themselves that it was 90 degrees. But we don't have time for that. So feel free to explore it if you can't get your head around it. But it's always a 90 degree angle when you have a diameter to a point on the outside edge of a circle. Right, the next one gets a little bit trickier. If we have 3 points on a circle that are not using the diameter, and we join them up, got a lot of bleed through on that one. Then if we join it to the center from the two of the points, I don't think I'm going to use the purple pen for this again actually. It bleeds through a lot. Right. Now this one we call the angle subtended by the arc at the center of the circle is twice the angle of the circumference at the circumference subtended by the same arc. Now that's a lot of words. What it means is if you look at this arc, from these 2 points, any angle didn't have to be there. It could have been over here, it could have been anywhere around that side, anywhere in that arc. That angle is always going to be half the size of this angle. So this, the center angle here, so this angle is always twice this angle. Now, as I say, it doesn't matter where we put that angle. So we could have it over here. Let's give this a go. As long as it's to the same 2 points, it's going to be the same size. Again, this is very useful sometimes in certain questions. So I am saying this angle and this angle are the same. This angle is twice as big. Okay. Right. Now to get on to some of the more interesting ones, but slightly less useful. Right. If I choose 4 points on the outside edge, and create a quadrilateral, a 4-sided shape, very deliberately not chosen a square or a rectangle. It works for squares and rectangles, but it's not so easy to see what I'm about to explain. Right. What we have here is a circumscribed quadrilateral. That means it's inscribed inside a circle. Circumscribed. Quadrilateral just means 4-sided. If we had a regular quadrilateral, we would have a square, because that means regular means all the sides are the same size, all the angles are the same size. So a rectangle is not a regular quadrilateral, but it is a quadrilateral. This shape is not anything special, it's just a quadrilateral. It's not quite a kite, it's not quite a trapezium. But because it's inside a circle, it gives us certain properties. This angle plus this angle will equal 180 degrees. And the same the other way. This angle plus this angle will equal 180 degrees. There are certain questions that have come up in past papers where you have a four-sided shape within a circle, and knowing that fact has saved you a good 5 minutes. There are other shapes we can put within circles. That's all in another video. Check it out. Right. One last one that I want to discuss in this video, and that would be the tangent. So if I draw a tangent, remember, is just a line that touches the circle at a point. So here's my point where it touches the circle. I can draw from that point a radius to the centre of the circle. Okay. That radius will always reach the tangent at exactly 90 degrees. Now, it can be a little hard to get your head around it at first, but if you think of a ball rolling along the ground, the centre of the ball is always directly above the point where it touches the ground. So it's always at a 90-degree angle. If we are given two tangents, as long as they are not on opposite sides, as long as they're not touching a diameter, we can always find a point where they meet. If it touched the diameter, it would be parallel. So if I draw on another one, and I am deliberately trying to make this, there we go. So there's our tangent and its radius. Helps if I get it straight, doesn't it? Right, and it's at 90 degrees. We know these are the same because they're both radius, but the distance from the tangent where it touches the circle and where the tangents meet will also be the same. So you actually get a kite. And because we know that that angle is 90 degrees, this angle is 90 degrees, and a full quadrilateral is 360 degrees, so we take away our 290 degrees, we know that we have 180 degrees left, and that is one of the properties of a kite. And that is that the interior angles and that add up to 180 degrees. Okay, and that's where we'll call it quits for this video.